Hello everyone. Today we are going to see the full guide how to install OpenCV uh, in our local system from its source code. So OpenCV is a open source computer vision library that is used for media file manipulation, such as if you want to work with some image processing or if you want to work with some video processing, you can use OpenCV. Very handy. OpenCV comes up with two flavors. One is the Python versions and another one is the C++. So if you want to use OpenCV with its Python versions, simply you have to write it pip install OpenCV Python. Okay, so as I have already installed within my system, so that's why it is saying the requirement already satisfied OpenCV Python in my local systems, and where it is installed, it is saying that it's installed some directory something. But the interesting thing happens if you want to build your OpenCV in your local system from the source code. And today we are going to discuss how to install OpenCV in our local system from the source code. So first step to get started with that, first install the dependencies. There are some dependencies involved while installing OpenCV, because OpenCV is actually written on C++. So if you want to compile that source code, you have to have the G++ compiler, and we need another two additional library or additional software in our system, that is called CMake, to generate the build script, and make to help us in installing the OpenCV packages. So what we will do is that we will do sudo apt install G++. Another thing is I think CMake, something like that, make and make. Okay, I think I am not spelling that well. Okay, we'll go to this thing and we'll see the okay, sudo apt CMake, only CMake, that's all. Okay, make, CMake and make. Oh no. Okay, as I have already installed those things, so that's why it is saying that G++ is already in the newest version, make is also in the newest version, so we no need to worry about these things. So if you are doing this for the first time, it will automatically install, and one thing will happen intermediately, that it will ask for if you want to install in your system or not. Just press yes. Why? That's all. You may know this thing. Okay, so once we have installed this OpenCV requirements or prerequisites, what we will do is that we will get the source code here. Okay, before that I will go to my here. As we are going to get the source code, you will get the source code from here. Just type install OpenCV, or you can say like OpenCV GitHub. It will give you the link to the OpenCV official repository. From there is two ways to install the OpenCV in your to get the source code in your local system. First one is that you can click on this code. It will give you this two tab. One is the local, one is the code space is no use of us, so we will go to this local by default, and you can, from here you can get the source code in two ways. One is that you will get the HTTPS link and you can git clone with this link, so that you can have this on your local system. Or another way is that you can download the zip file of OpenCV this repository. What I will do is that I will clone this repository using git clone. I will do git clone and paste this link, and it will clone the OpenCV repository in my local system. Okay. Let it. So it's a quite a heavy repository. It may take some time depending on your systems or local area bandwidth, local area network bandwidth. Almost done. Okay, done. So we'll see that what is inside of this repository or inside of this directory. So you can see that there is one directory called OpenCV. Okay, we will go to this directory called OpenCV and we will see what is inside of this thing. What you can see is that this kind of there is many things are there. One is that CMake list, we will discuss on things in details. Another one is some sample security readme file license and everything, blah blah things happened. Things are here. So what we will do is that we will get out of these things and concentrate and pay attention. What we will do is that we will make a directory called build. Okay, now we will go inside this build directory. So what is the importance of this build directory is that whatever the files and packages are going to be installed in our local system will be found here only inside this build directory. Okay, so all the files and packages will be situated or will reside inside this build directory. And now we will jump into the final step, or the most important step while installing the OpenCV is that first there are three steps comprises of this one. One is that generating the build script, then we will build the OpenCV packages and everything, and third step is that we will install that OpenCV. So installation will come at the end, but before that we will have the two another steps. First one is that generating the build script, and second one is that based upon the generated build script we are going to build the packages. So okay, so first step is that generating the build script. So you remember at the beginning of the video we have installed that CMake. The importance of the CMake will come now. The importance of the CMake is that now CMake will help us to generate the build script. So how it is going to help us? So if you look at this thing, you will see that there is one thing called CMake list. See, this one is the CMake list. So CMake list contains all the dependencies packages, all the rules inside of this CMake list text, so that we can use the CMake to build the to generate the build script. So how we will do that? We will CMake and dot Now what will do that in the generic term? Okay, let me clear the screen so that it will make more. So CMake, and there are two things that you have to give. One is that the configurations that you want to provide the OpenCV to build, to generate the build script. You can raise different flags. Let's say if you want to uh, configure your OpenCV with GStreamer, you can do that here. If you want to make your OpenCV to compile with CUDA, you can do that here by raising a flag. And if you want to, or any other stuff, if you want to incorporate some codec on your OpenCV, you can do that by here by raising some flags. But as of now I will use the default flags. I will not change anything because that will lead us to the another round of sessions. And second thing that you have to do is that you have to provide where this CMake list actually situated in. So what I mean is that CMake, you can see this CMake will look for a CMake list.txt file. So where it will look for this CMake list.txt file, you have to give the path of that. So as it is resides in the OpenCV directory, we will give that OpenCV directory and we will press enter, and it will start generating the build script. So hold your breath and enjoy this process. It's downloading something, IPPICV. I'm not sure about what is this thing used for, but as I can see is that it's something related to OpenCV third party library. Okay, let it do its work, then we will jump into our stuff. It's still downloading. Okay, it's saying that this configuration is done and generation is also done, and I can find the build files inside this build directory. So let's see what this configurations has been done. What are the configurations been done? So here is the general information, general configurations about the OpenCV that is going to be installed and for which this build script is being generated. So first thing is that it's saying that OpenCV that we are going to use, it's a 4.8. Okay, and other metadata related stuff is that when I am recording this video or I am going to install this, and what are the CMake versions, and what is the CMake generator that is being used, and blah blah things. Here it's a dynamic libs or not. So interesting part that I'm going to show you is that, okay, yeah, this one. So it's about the GUI. It's saying that it's compiled with GTK plus, and the GTK that is used by this OpenCV is 2.24.32. okay, and about this media files, basically media files are referred to as the image files, and it is compiled with JPEG. So JPEG is a compressor that image file is actually used, and it's saying that this JPEG is a codec. So it's saying that JPEG codec is compiled with WEBP, is compiled with PNG, TIFF, JPEG, and other steps are there. All it's saying that it's already compiled with this OpenCV. And with the video perspective, it's saying that no, it is not compiled with FFmpeg, it is not compiled with advanced video. AV stands for advanced video. This one, advanced video codec, no. Advanced video formats, no. Advanced utils, no. And it's saying that no, it's not compiled with GStreamer. So it's not go. If you want to use the GStreamer, if you want to use the OpenCV in your GStreamer, then this installation is not going to help you. But it's compiled with V4L2 SRC. So it's compiled with V4L2 SRC. That means that if you want to use your V4L2 SRC, you can use this OpenCV. And it's saying that okay, OpenCV, yes, it is compiled with OpenCL, sorry. And where you will find that, from here, include path here. And for the Python 3, I don't know why this is using Python 3 as well. So Python 3, it has found that it has used Python 3 from my local systems root underscore usr bin Python 3. NumPy is also being used for this thing, and install file is here. If you want to use that Python bindings, it is saying that you can find this thing inside this thing, lib Python 3.8 site packages cv2 Python 3.8. okay. And Java, it's almost all the components of the Java are not being compiled with these things, and this OpenCV is going to be installed inside. So this object file or binary file is going to be installed inside that USR local directory, and that's why it's saying that okay, this whole configuration is being done now. And then you can remember, after this configuration is being done, it was paused for some times. It was not pausing, it was not printing, because it was generating the build script according to these configurations. So now it is saying that it is generating the done. That means that build script is being done, and this build script is located inside this build directory, that is my present directory. So let's see what is inside my present directory. Okay, if you look at this thing, there are so many things are there. So one thing that is important for us to proceed with the next step is that this make file. So once we have our build script ready, what we have to do is that we have to build from that build script. So for that, this make file is going to help us. So this make file is going to help us to install, or to not install, to build the packages inside this directory. or whatever you want to choose, but here on this video I will focus here, I will focus only on this directory only. So okay, so what I will do is that I will make use of this make file and will build the packages. So for that what I have to do is that make -j and the number of CPU cores that you want to use to proceed with this computations. So for this thing, as my system is an 8 core system, but I will use the 4 cores, I will remain those other 4 cores for other steps. So I will type make -j4 and it will start building the packages. Okay, and it will take some time depending on the computations of your systems. So once it is done, I will come back to you.